Hello guys, welcome back to Step Ahead. This side Lakshit, and today we are going to make a program to check whether the number is prime or not. Also, we are also going to optimize the our basic program, right? So, what is a prime number? Everyone knows that a prime number is a number which is divisible by 1 and itself n, right? So, what we have to do in this is that we have to check whether the number is divisible by any of the number lying between 2 to n minus 1, right? And if number is divisible by any of these number, then number is not prime, right? And if it is not divisible by any of these number, then the number is prime, right? And one more thing I want to discuss is about test cases, right? So let me open a question of prime number. So this is Geek for Geeks, and let me go to coding practice. Let me search for prime. Wait, let me search for the question. Prime or not? This is the question. So see, what is this question? Is that for a given number n, check it is prime or not, right? We have to check whether it is prime or not. A prime number is a number which is only divisible by one or itself, right? So what you have to give in input is that first line contains an integer, the number of test cases t, right? And then we have to enter the number n, right? So what do you think is test cases? So let me discuss. Test cases is that the program should run. Let's suppose the test case is equal to t. So the program should run t times. T times, right? Suppose you made a program. Suppose this is our program. Check whether number n is prime or not, right? So what will happen is that we will give it input n, it will process it, it will run, and it will give output prime or not prime, right? What we want is that this program, this process should repeat t times, right? This is what we want. This is what a test case means, right? That this program should run t times, right? So what we will do is that we will add another loop while t is greater than 0, and we will do t minus minus in the end, right? And we will write our this code inside it. We will write our code inside it. So what will happen? Let us see. Suppose initially t was equal to 3, right? Suppose that we give input t is equal to 3. So initially t is greater than 0. This program will run first time, right? Now the value of t will become 2, right? Then again it will check 2 is greater than 0, right? This program will again run, right? So the value will increase to 2, right? The program has run 2 times. Now the value will decrease to 1, right? Now 1 is greater than 0. This program will again run, and the total times the program will run is 3 times, right? So this is what we will do to include the concept of test cases. Now let us make a program, right? So this is GDB compiler. This is hashtag include. So first of all, what we will do is that we will take integer, we will declare an integer t, and we will take input integer t, right? Now what we will do is that the while t is greater than 0, t minus minus, right? This is where our while loop ends. And I hope you remember that t minus minus means equal to t minus 1, right? I have discussed this in previous video of operators and global variable, right? So now what we will do is that we will declare an integer n and we will take input n, right? Now we have to check whether this is prime or not. So now let us declare an integer times, right? I will discuss the concept why we have declared integer times here. So what we will do is that for integer I is equal to 2, I less than n, I plus plus. Let me write it first and we will discuss what does it mean if n remainder with I is equal to 0 times plus plus, right? What we will do then is if, so now let us discuss what we need to give output, right? So if a number is prime we have to give output yes, else we have to give output no, right? For each test case in a new line, right? So we have to add and del in the end, right? Print yes, number is prime, else print no, right? So if times is equal to 0, cout yes with in a new line and end the line, else what we have to do is that we have to cout right and end the line. So what we are actually doing is that so now let us discuss what I am actually doing. Right? So I have declared integer t here, right? And I have taken input. I have taken input here, right? I have taken input here. Now what I have done here, right? I have maintained a variable times. How many times the remainder will equal to 0, right? We have to check between 2 and n minus 1, right? So what I am doing is I am running for loop and as many times as remainder is becoming 0, right? If remainder is becoming 0, it means that n is divisible by I, right? I is lying between this. So the value of times will increase, right? And you know that times plus plus means that times is equal to times plus 1, right? I have discussed this concept in this is basically short form of writing this. I have discussed this in video operators. And now if I now the loop ends, right? If times is equal to 0, what does this means that the number is not divisible by any of the number 2 to n minus 1, right? So we will do cout yes because it is only divisible by 1 or n, right? If it is not equal to 0, right? Then we have done cout no, which tells that number is not prime, right? Right. And one more thing. Now, right, is there any another erase or link? So now one more concept I want to discuss. Suppose n is equal to 2, right? we are checking from 2 to n minus 1, right? So we are also considering 2, right? So 2 will divide 2, right? Remainder will be 0 and times will be increased, right? In this case, the time will not be equal to 0. What do you think? In this case, the output will be yes or no. Because we are also considering 2 here. And suppose we take n is equal to 2, right? So what will happen is that 2 will leave remainder 0 on dividing by 2. The value of times will increase, right? And then this loop will not run, else loop will run, right? So you must be thinking, some of you must be thinking that output should be no, right? But no, you are wrong, that output will be yes only. Let me discuss why. There is a simple concept. We also need to check the condition here, right? Suppose we took n is equal to 2, right? So, and I is also equal to 2 initially, right? So 2 is not less than 2, right? This condition is wrong. So this while loop will not run, right? So if this will not run, times value is equal to 0, right? Because compiler denotes the value equal to 0, right? And if we doesn't initialize it, and it will give output yes only, right? So this was the uh, extreme case which we have to take care of, whether we are getting right input output or not, right? So now let us run the program, right? Now let us run the program. So for just our let me just initialize times equal to 0 and let me just now run it, right? So let the value of test case be 1, right? I need to run it only one time and let me enter 2. So we are getting yes. Let me run it again. Let me enter test case equal to 3, right? So let me initially enter 5. So you can see it gives yes, and now you can clearly see that program hasn't stopped because the program will take total 3 inputs, right? Let me add another value 4, right? So we are getting more, right? Let me add something like 13. So it's giving yes. So our program is running fine. Now let me put this. Let me just check it here, right? Let us see what we get. Let me just submit it. So you can see that our answer is not right, and the reason is your program took more time than expected, right? Expected time in most of the cases, the default time is 1 second, right? But expected time is one. Our program took 1.12 seconds, right? So what is the hint? Please optimize your code and submit again, right? So this is where, or this is why competitive programming is required, right? This is why one of the main important reasons why competitive programming is required. You can optimize, you can think and optimize the solution in a better way, right? Can you can actually then submit, get successful submissions, right? Life will become much better, right? So now I have already discussed the concept in the video, in the previous video of, and of it is named as jails, right? It is the jail problem. I will add it to the I icon above, and you can watch it if you haven't watched. And if you still have any confusion regarding the concept, do watch the video again. So in the video, I have discussed that devices occur in pair if number is not perfect square, right? And another thing is that devices occur in odd number. Only one number is not in paired form, which is its square root, right? Let me just uh, explain it in short form. Like for 7, the devices are 1, 7, and 1, 7, only 2, right? This is a prime number. Let us leave this. Let me take 36, right? So its pair are 1, 2, 3, 4, 6, and 9, and again then 12, then 18, and then 36. So you can see that its square root is 6, and you can divide the line here, and you have even devices across this, right? They all occur in pairs. Similarly, if number is not prime, let's say 24. So what are its pairs? 1, 2, 3, 4, 6, 8, 8, 12, and 24. And its square root is nearby around 4 point something, right? So it will lie somewhere here. So you can see that across the square root line all occurs in pair, right? So what we can say is that if the if there is no divisor, there is no divisor till the square root, right? Suppose that there is no divisor till the square root line, right? Then there will be no divisor in the later stage, right? We can say that if there is no divisor here, right? Except one, right? We are excluding one. We are starting from two, right? So, and we are also excluding the last number 1 and 24, right? So we are 1 some pair, this is the square root line, and n. We are excluding these pairs, right? We are considering from 2 to n minus 1. So if there is no divisor lying here, then surely there will be no divisor lying here, right? We can surely say this because of this concept, right? So what we will do is that we will only run our program till I less than equal to root n, right? Less than or equal to. We are doing equal to because a number can be perfect square, right? In case of 36, we have to also consider the case of 6, right? So we are doing equal to, right? So what we will do is that I should be less than or equal to root n, or we can say that I star I should be less than or equal to n, because I square is equal to n and I is equal to root n, right? So multiplication is easy, right? Because there is no operator for root n, and finding root is a difficult task, and we will discuss later, right? So this is much easier because there is multiplication operator. So we will just apply this, right? And let us apply this and check what happens. So what I will do is that I will just do that I star I is less than or equal to, right? So let's submit it again, right? I star I should be less than n, or I should be less than or equal to root n, right? So now you can see that the execution of the time has reduced to 0.01 seconds, right? So you can see that our program has optimized from 1.12 seconds to 0.01 seconds, right? So you can see how much big difference is there, right? So I hope that you got this concept, and I hope you like the video. Please share and like the video, and thank you for watching. Comments and doubts, you can mention your comments or doubts in the comment section below. Right, thank you.